Okay, students, in the last lecture, we have started the topic as oscillation. And in that lecture, we have seen the differential equation of linear SHM. And in that differential equation of linear SHM, we have seen d square x by dt square plus omega square x is equal to 0. So that is our first part. That is, in the previous lecture, we have seen how to derive the differential equation. Then, also in that same lecture, we have seen from differential equation how we can find out the acceleration. So, from this differential equation, we have find out the acceleration. That is, acceleration is equal to d square x by dt square is equal to minus omega square x. And from this acceleration, we have find out the velocity. So this velocity expression we have derived, velocity v is equal to omega under root of a square minus. So up till this, in the previous lecture we have studied. Now, in the today's lecture, I can explain from velocity, now we have to find out the displacement. Now this velocity expression, I can write down as it dx by dt. Instead of velocity, I will write the formula dx by dt, which is equal to omega under root of a square minus. Now what I will do, I will take x term at one side and time dependent term on other side. So x term at one side means what I can say dx, and this term which include x under root of a square minus x square, that I will take it for the division. So under root of a square minus x square, which is equal to this omega as it is, and this dt in cross multiplication I will take it for the multiplication. So I am getting dx divided by under root of a square minus x square omega t. Now I want to find out x from dx, means I have to integrate this equation. So I will say that integrating this above equation. So this equation I can integrate. So integration means what? I put integration sign. So integration of dx divided by under root of a square minus x square is equal to integration of omega into dt. Now I will integrate. Now integration, what I am getting? Integration of 1 upon under root of a square minus x square into dt. Now this integration has a standard formula which is equal to nothing but the sine inverse here x upon a. Is it right? Okay. Now one mistake is there. Instead of small a as amplitude, I will take it as a capital A. So everywhere instead of small a, I will replace it by capital A. So I am getting here sine inverse x upon a is the standard formula for integration of dx divided by root of a square minus x square. It is equal to omega is a constant, and now integration of dt. Integration of dt is nothing but the t. So now I can write down this arranged equation. I can write x upon a is equal to sine of, here I can say as a sine of omega t plus alpha. This alpha is nothing but the integration term. So here I can say alpha is nothing but the integration term. So I get it, x is equal to a sine omega t plus alpha. This is nothing but your equation of displacement. So now this first equation I am getting equation for acceleration, second equation I am getting for velocity, and this third equation I am getting for displacement. So this is your 3-mark question. What is that? Write down differential equation of linear SHM, and you have to write down, you have to derive for acceleration, velocity and distance. So in that manner, you can cover up your 3-mark question. Got it? Any doubt? Now, I have to concentrate on this displacement equation. Now this displacement equation, x is equal to, here I am getting x is equal to a sine omega t plus alpha. Taking reference of this displacement equation, now I can derive the next two more equations for the displacement. Now what is that? In previous lecture we have seen, whenever I am considering linear ascension means what? Particle is moving along a straight line. When it is moving along a straight line, it will move to and fro. So it will be moving in the forward direction. It will be moving in the backward direction. So this O position is nothing but the mean position of the particle. And this A and B are nothing but the extreme position of the particles. So here for A position I can say positive extremity. And for B I can say as a negative extremity. Now, when my particle is at mean position, so I'll write it here, mean position. When my particle is located at mean position, means what? There is no displacement. It is not moving towards A, it is not moving towards B. Particle is at mean position. So your x is equal to, when your time interval, I am saying that at time t is equal to 0. So at these two conditions of mean position, I can use in the displacement equation. What is my displacement equation? X is equal to A sine omega t plus alpha. In this equation, I can use this above two condition. So if I use that condition, what I write? Instead of x, I write 0, which is equal to A sine, here t is equal to 0, means omega multiplied by t. T is 0 means what? Omega term will become 0. So what I am getting 0 plus, means what I write? 0 is equal to A sine of alpha. Now A sine alpha, these two terms are in product. Their product is 0. Meaning is what? Either A is 0 or sine alpha is 0. So I say either A is equal to 0 or sine alpha is equal to 0. But this A is equal to 0, this condition is not possible. Because when particle is in the oscillation, the particle must have an amplitude. So A is never to be 0. If A is never to be 0 means which condition must be true? Sine alpha must be equal to 0. So what I'll say that if sine alpha is equal to 0, meaning your alpha angle must be equal to 0. Or I can say that alpha is equal to 1. Means now this value of alpha I can put it in the displacement equation. So if alpha value I put it in the displacement equation, what I am getting? X is equal to A sine omega t. I have to put alpha is 0. So I put alpha is equal to 0. So what I am getting displacement equation? X is equal to A sine omega. So this is nothing but the displacement equation when particle will starts from mean position. Is it right? So this is your 2-mark question. I will again repeat. What we want to find out? We want to find out what is the displacement equation when particle will start from mean position. So now, when particle will be starting from mean position, means its displacement is 0. At time interval t is equal to 0. So at mean position you have these two conditions. That is at mean position displacement is 0 when time interval is 0. By putting that condition in the displacement equation, our displacement equation is what? X is equal to A sine omega t plus. In that equation, I'll put first x is equal to 0. So x is equal to 0 is equal to here A sine t value if I put 0, so 0 into omega means 0 plus alpha means I am getting 0 is equal to A sine alpha. alpha, this product is equal to 0. So two numbers having product and their product is 0. Means either any one of the number must be 0. So I say that either A is 0 or your angle sine alpha must be 0. But A is not to be 0. Why? Because A is nothing but the amplitude. When particle is performing oscillation, so this is mean position. When particle will oscillate, so it must have a certain amplitude. So A term will be never to be 0. So if A term is never 0, then what is the possibility? Sine alpha must be equal to 0. If sine alpha is equal to 0, means your alpha value must be 0 or 1. So this condition of alpha, I can put it in your displacement equation. Your displacement equation x is equal to A sine omega t plus alpha. So at mean position, what I am getting? Alpha is equal to 0. So that value I will put it here. That is at mean position, alpha is 0. If alpha is 0, what I am getting? Displacement equation. Displacement equation x is equal to A sine omega t. This is nothing but your displacement equation. Clear? Any doubt? Fine. Now, next thing I will say that now I will switch over to when particle is at extreme position. So now I will say that now particle is at extreme position. Now extreme position means what? Your particle is situated at point A. So its amplitude is plus A. And if I am saying that the particle is situated at B, so its displacement is minus. Means now your particle is not located at O. Either your particle is located at A, positive extremity, or particle is located at B, that is negative. Now when your particle is at A, then from main position, its displacement is plus A. And when your particle is at B, then its displacement from the mean position is minus A. Means what I will say that x value may be plus A or x value may be minus A when particle is at extreme position. Particle is at extreme position, we are starting the motion, so initially time interval is 0. Now putting these two conditions in your displacement equation is what? X is equal to A sine in bracket omega t plus alpha. Now in that equation I am going to put these values. Which values? X is equal to plus minus A. So instead of x I put plus minus A is equal to A as it is sine in bracket omega as it is value of t is 0 plus alpha. So what I am getting? Plus minus A is equal to A into sine omega multiplied by 0, that is 0. 0 plus alpha is alpha. Okay, now from both sides this AA factor will get cancelled. What is remaining in the left side? Plus minus 1 is equal to sine of. Means what? Sine alpha value is plus or minus 1. When I am getting sine alpha 1, I will get sine alpha 1 when alpha is equal to pi by 2. And when I am getting sine alpha is minus 1, when your alpha value is equal to 3 pi by 2. Right? So at this angle pi by 2 and 3 pi by 2. Pi by 2, your angle value is plus 1. 3 pi by 2, your angle value is minus 1. So that reading, that value of alpha, I can put into this displacement equation. So now when my particle is at extreme position, I will say that equation will become x a sine of omega t plus. Now what I want? Your alpha value must be pi by 2. So I will say alpha value is equal to pi. Now omega t plus pi by 2. Pi by 2 means 90. any angle plus 90. So omega t, I can say that theta. Theta plus 90. So you have a trigonometric identity. Sine of theta plus 90 can be written as the cos of theta. So I can use this trigonometry identity. Now here in this equation, my theta is what? Omega t. So what I say that I get displacement equation x is equal to a cos of omega t. And this is nothing but my displacement equation when your particle will start from extreme position. Clear? Okay, now all steps are in front of your screen. Everybody is observing these steps. So go through each step and see that how I am getting equation for displacement when particle will start from extreme position. So go on repeating that steps, just concentrate it carefully and then we can proceed further for the next derivation. So very important thing you have to remember that mean position means excessive. Extreme position means both extreme, plus minus. So x is equal to plus minus. And using that we can find out the thing. And one more important thing, when particle will start from mean position, your alpha value is, and when particle will start from extreme position, your alpha value is 5. So it is, you have to remember for MCQ question. Alpha is what? Initial phase angle. So your MCQ question, when particle will start from mean position, what is the initial phase angle of the particle? What is that? 0. Next MCQ question. If your particle will start from extreme position, then what will be the initial phase angle? So your initial phase angle should be clear? Any doubt? Everything is clear now? Fine. Now we are going to switch over to the next equation. That is what will be the maximum and minimum values of displacement, velocity and acceleration when your particle is performing linear acceleration. So now you have to recall your all equations. First equation for displacement, from that I can go for velocity and then from that I can go for acceleration. Okay, fine. Your x displacement equation when particle is performing SHF. Just now we have seen when particle is performing SHF, x is equal to a sine omega t plus, right? Second equation, I can write for velocity. The second equation of velocity I can write down, that is your velocity v can be written as v is equal to a omega cos of omega t plus alpha. Or I have one more equation we have derived, it is omega under root of a square minus, this is the velocity equation. Third equation is of acceleration. Acceleration is minus a omega square sine of omega t plus alpha, which can be written as minus omega square into this already we have studied. Now from this, now we can find out what will be the value of displacement, velocity and acceleration at mean position as well as at extreme position. And this chart is very important for your MCQ question, your numerical problem, your 1 mark question. Right? Okay. Very simple. Mean position. Mean position means what I can say that displacement x is equal to 0. So at mean position, your first point displacement is 0. Then what is the displacement at extreme position? At extreme position, your displacement is plus minus capital A. How? See this diagram. Linear ascension along a straight line. Particle is initially at mean position. When it moves to extreme position A towards the positive axis, so its displacement, I can say that positive displacement, that is positive amplitude, which is plus. When particle is moving towards negative extremity, at that time its amplitude is minus. Fine? That is available here. That is at mean position, x is equal to 0. When your particle will go to A, its amplitude is or displacement is plus A. When it will goes to B, its displacement is minus A. Clear? So this at mean position, what I can say that displacement is minimum. At extreme position, your displacement is maximum. Okay, now I can write for velocity. Velocity at minimum position. What is the velocity equation? V is equal to omega under root of a square minus. At mean position, what do you think? Your displacement is 0. Means x is equal to 0. If x is equal to 0, what equation I can write? Omega under root of a square minus 0. So a square minus 0 means it is a square. Square root of a square is nothing but a. Means what I write it here? This v is equal to, here your velocity is plus minus. So plus minus a into a. Okay. Now at extreme position here, what is velocity equation saying? Velocity is equal to what? Plus minus omega under root of a square minus x square. But at extreme position, what is value of x? X is equal to positive negative a. So I can put that value. So plus minus omega under root of a square minus, instead of x, I can put value plus minus a and square of that. So square of that will become a square. So a square minus a square means what? 0. 0 multiplied by omega means what? 0. So at extreme position, what I am getting? Velocity is. So velocity is 0 means what? This is the minimum value of the velocity. And v is equal to plus minus a omega means this is the maximum velocity. So v max is equal to plus minus a omega, and here v minimum is equal to 0. Here means when particle will go to extreme position, its velocity of the particle will become 0. And when particle will come back to mean position, at mean position its velocity will become maximum. That's why if you are concentrating an example of pendulum, see here, pendulum is at mean position. Right? When you apply a force, pendulum will get displaced from mean position to extreme as a position. When it will go to extreme, its velocity will become 0. As its velocity will become 0, that's why this pendulum will come back to mean position. When it will come back to mean position, its velocity will become maximum. When its velocity is maximum, due to inertia, it will automatically go to the next extremity position. So here your velocity will become again 0. At B, when it will become 0, again it will come back to the position. So like that manner, your pendulum will swing between one extreme position to another position. Why? Due to this velocity. So now this is very important thing. That is, your velocity is maximum at mean position, and value of maximum velocity is nothing but a. and velocity at extreme position is 0, which is nothing but the minimum value. Fine. Now I can go for the third value. Third value is nothing but the acceleration. Now our acceleration is equal to nothing but minus omega square x. At mean position, what is the thing? Displacement is 0. That is x is equal to 0. So I can put that value. Minus omega square multiplied by 0. Means what I am getting? Acceleration is equal to 0. 0 means this is the minimum value. Means at mean position, I am getting acceleration is minimum. That is 0. And now here I can write down acceleration at extreme position. Again, acceleration, same formula. Acceleration is equal to minus omega square x. What is x value? X value is plus minus capital A. So what it will be? Plus minus omega square A. Means at extreme position, the acceleration is nothing. Clear? So see here, when displacement is maximum, acceleration is maximum, but velocity is minimum. When? At what position? At extreme position. So now, see, particle is at mean position, its displacement is 0, but its velocity is maximum, which is equal to a omega. As its velocity is maximum, it is moving in the forward direction up till A. When it will go to A position, that is extreme position, its velocity will become 0. Though its velocity is 0, but it will not stop there. Why? Because at extreme position, its acceleration is plus minus omega square A. So due to that maximum acceleration, it will again come back to the mean position. When it will come to mean position, its acceleration will become 0. When again it goes to extreme position, its velocity will become 0. But its acceleration will be become as a minus omega square A. And therefore, your pendulum will be swinging in between two extreme positions. So in your textbook, in a square box, you have a certain question. See that, what type of questions are there. So I'll just read out that question. You have given the first question as a state at page number 114. Can you tell under that? State at which point during an oscillation, oscillator has zero velocity but positive acceleration. During oscillation, at what point oscillator has zero velocity but positive acceleration? Zero velocity, positive acceleration. Which point is that? Positive extreme point. Clear? Next question. During which part of the simple harmonic motion, velocity is positive but displacement is negative and vice versa? Now, when your particle will start to moving from velocity v is equal to 0 to v max is equal to omega. Means now when particle will moving from A to O, velocity is positive. But now displacement is what? Decreasing. Means displacement is negative. So when this will happen? When particle is moving from positive extreme position to mean position. During that motion, particle has a positive velocity and negative displacement. But what happens in the negative extremity? In negative extremity, velocity is 0. But displacement, you are moving towards mean position, means you are moving towards positivity. So what I can say that velocity will be moving from 0 to maximum, means velocity is positive. Displacement is also positive. When your particle is moving from negative. So all these points are important for 1 mark question as well as for your test question. And the last question given, during which part of the oscillation the two are along the same direction. Two are along the same direction means what? Velocity is also positive, displacement is also positive. When it is possible, when particle is moving from negative extreme point to mean position. At that time, velocity is positive and displacement is also positive. Because you are moving from negative to positive. You are moving towards the positive. Clear? So in that manner, you can say the maximum value and minimum value. So now these important formula you have to remember. What is the formula for V max? Velocity maximum is equal to A omega. What is the formula for acceleration maximum? Acceleration maximum is equal to positive negative omega square. So these two formulas are very, very important for your numerical problem, 1 mark question, as well as for your question. Now see that on that same page, 114, you have example number 5.4. And in that 5.4, you have given that velocity equation. And one more example, 5.5. In that 5.5, you have given the example of maximum velocity. And 5.6 is also regarding maximum velocity. So in that both problem, they have used Vmax formula as well as Amax. So go through that two examples carefully so you can come to know that how to solve the examples. When problem lecture is there, at that time I am again going to take this problem. But now I have taught you about Vmax and acceleration maximum. That's why you have to see that problems. Problem number 5.5, 5.6 on page number 114 and 115. So go through that problem very carefully. Clear? Any doubts? Okay. Now I can explain the term as an amplitude, then period, frequency. These terms now I am going to explain. Right? Okay. So the time when I am cleaning the board, just relax so that you can easily pick up the next point, whatever I am going to give as a three terms: amplitude, period, and frequency. So now, first I will say that amplitude of oscillation. Now, what is that? Let's consider. This is the path along which your particle is moving. So your particle is moving from O as a mean position to A as a positive extreme position, as well as it will moving towards B, where B is the negative extreme point. So when particle is moving through a displacement O to A, so this is called as maximum displacement of a particle from the mean position, which is to be called as the amplitude. But this amplitude lies on positive x-axis, so I can write down plus. Why? When particle is moving from O to B point, so this is also the maximum displacement of a particle from mean position to the negative extreme point. So this distance is also called as a, but along which direction? Left. That is negative x-axis. Negative x-axis, that's why I say that amplitude is. So what do you mean by amplitude? Amplitude is the maximum displacement of a particle from the mean position. Maybe towards positive extreme point or maybe towards the negative. And amplitude is what? Amplitude is a distance. As it is a distance, so it is either measured in terms of meter or it is measured in terms of centimeter. Clear? Any doubt? second term I can explain as a period of S. Now already this period word you have seen in the previous standard, 11th standard. You have seen like a period of satellite, period of a particle performing a circular motion, or period of a rotational motion. So period is what? Period is nothing but the time taken by the particle when particle is performing one rotation or one revolution. That is called the period. Now here what is the thing? Period is the time taken by the particle when particle is performing one oscillation. Will again repeat. Period of a SHM is defined as time taken by the particle when particle is performing one complete oscillation. Now, one complete oscillation means what? Particle is moving from O to A to O, O to B, and B to C. So this four distances particle is covering. Then particle has completed one oscillation, and for that one oscillation, whatever time is taken, that time is to be called as a T. Is it okay? Now, see here. When particle is moving from O to A, displacement is plus. When particle is moving from extreme to O, extreme means maximum to minimum, means displacement is minus. Then it is moving from 0 to B, minus. And B to A, plus. Now my question. You are knowing two physical quantities are different, whatever I am calling now. First I am going to call distance. How much distance is covered by the particle during its one oscillation? Distance. How much distance is traveling by the particle when the particle is completing one oscillation? So see that during one oscillation here distance is A. Here distance is A. This distance is A and this is also A. So distance traveled by the particle, I can say distance traveled by the particle is equal to 4A. Clear? But what is the displacement of the particle? Now displacement is a vector quantity. Distance is a scalar quantity. Displacement is a vector quantity means you have to think about the direction. So see here, O to A, positive direction. A to O, negative direction. O to B, negative direction. B to A, positive direction. You see that? You can add all these things. So what I am getting? Displacement is clear? So you have to remember this point for your consideration. Fine. Now, here, now I can say that you have a displacement equation. X is equal to A sine omega t plus, this is nothing but your displacement equation. Now in this displacement equation, if I am saying that your time interval t will get replaced by t plus 2 pi upon omega, means I will say that t I am going to replace by t plus 2 pi upon omega. Now why is this so? Because I want to prove that this 2 pi upon omega, this term is a period. Clear? So now in the displacement equation I can put it this x a sine omega. Instead of t I can put t plus 2 pi omega bracket complete plus alpha bracket complete. Only t is replaced by t plus 2 pi by omega. Now by this omega I can multiply inside. So what I am getting, x is equal to, see here, a term as it is, sign as it is, in bracket omega by omega I am going to multiply inside. So omega into t is omega t plus omega into 2 pi upon omega. So omega into 2 pi upon omega plus omega omega here will get cancel. What I am getting, x is equal to a sine omega t plus 2 pi plus alpha. And you have a trigonometry identity. Sine of 2 pi plus theta can be written as a sine theta. So you have here is a 2 pi and theta is what? Omega t plus alpha. So what I write down? X is equal to a sine omega t plus alpha. This equation I can write in this manner. Means what? I am getting first equation only. Means what? The displacement of the particle will get repeated after time interval of what? Time interval of 2 pi upon. Therefore, the period of SHM is nothing but 2 pi upon. So after this time period, the motion, the displacement of the particle will get repeated. Clear? So this is about the period. If this is the period, then I can define the third term, which is to be called as the frequency of SHM. Frequency of SHM. Frequency is denoted by letter F or small n, which is equal to reciprocal of period. That you are knowing. Already you have seen. So as it is a reciprocal of period, means that what I will say is omega upon 2 pi. So that is nothing but your frequency. Clear? So these three terms you will get it. Explain any two terms. Amplitude of SHM and period. So for 2 marks. So you have to remember the definition of this. First definition is of amplitude. What is amplitude? Amplitude is the maximum displacement of the particle from its mean position. And period is what? Time taken by the particle to complete one oscillation is to be called as a period. And frequency. Frequency is what? Number of oscillations per unit time is to be called as your frequency. Clear? So all that things you have to read it carefully so you will get the frequency. Is it okay? Now here for frequency I will give one more formula. What is that? If you are remembering, that is in differential equation, we have written one replacement. If you are remembering that, you can read it to me. In differential equation of SHM, we have seen omega square is equal to k by m. Therefore, omega is equal to under root of k by m. And what is period? Just now we have seen period is equal to 2 pi upon omega. Here I can put the value of omega. So 2 pi omega value under root of k by m. So what I write it? Period t is equal to 2 pi under root of m by 2. So this is the formula for period when particle is performing. Then what is frequency? Frequency m is the reciprocal. So 1 upon 2 pi under root of k by m. This is nothing but the frequency. Clear? So these formulas are very, very important. Period formula when particle is performing. Is it okay? Any doubt? So see here, these formulas are very important. So Now I can again revise what the things today we have seen. So the first thing we have seen as a displacement of a particle when particle will start from mean position. That is x is equal to a sine omega t. When particle will start from mean position. Then we have seen displacement equation when particle will start from extreme position. Clear? Then we have seen Vmax formula. Vmax is equal to positive negative a omega. Then we have seen acceleration maximum, which is equal to positive negative a omega. Right? After that, we have seen period formula and frequency formula. So these 6 formulas are the key point of today's lecture. Fine? Now I'm going to stop. The next part we can see in the next lecture. Okay. Have a nice day.